All right, so we're going to solve by substitution. So solving by substitution, by the way, I'm going to zoom out a little bit. This is on page 20. This is lesson 7, okay? Solving systems of equations by substitution. So this is the last lesson in the unit. So we're going to solve by substitution, which means you solve one of the equations for one of the variables, and then you plug it back into the other equation, okay? Again, just like last time, we're going to follow these steps as we go, okay? So the first step says solve one equation for one variable. For example, we're either going to put one of the equations into x equals or y equals. Do we have either an x equals or a y equals? Yes, we have an x equals. So I'm going to use this equation, and step 1 is already taken care of for me. Step 2 says substitute this expression into the other equation and solve for the missing variable. Okay, so I'm going to substitute this in for the x in the other equation. So instead of x plus y equals 4, I'm going to write, okay, pay attention here because I think this is where students get confused. So let me erase all this over here. X plus y. Okay, my x is also equal to 2y minus 5. So instead of x, I'm going to write 2y minus 5 plus y equals 4. Notice I didn't change anything else, but my x is also 2y minus 5. So I just substituted in 2y minus 5 for x. And then I'm going to solve and continue to just solve. So 2y plus y is 3y. I'm going to add 5. So 3y equals 9. Divide by 3 and y equals 3. So that's one of my answers. And then that's step 2. Step 3 says substitute your answer into the first equation and solve. It doesn't matter if it's first or second equation. So I'm going to choose the one that's easier. Well, if I look at my bottom equation, you see how my x is already alone? That's way easier because I have my y, which is 3. I'm going to plug that in for y here. And I'm going to solve for x, which is already solved for. Actually, I'm just simplifying. So 2 times 3 is 6. And 6 minus 5 is 1. So my answer is 1, 3. And that is my final answer. Always write it as a point, x, y. I should add that here, huh? Write your answer as a coordinate. Okay, now for the second example, do you see how step 1 says solve one equation for one variable? So we're either going to put it in what x equals or y equals. Now, I don't have an x equals or y equals for my bottom equation. I have 3x plus y equals 4 and 2x plus 5y equals 7. I don't have either one in x or y equals. Now, which one is easiest to get alone? I would say the top equation. Notice how the y is already by itself, right? So I'm going to say, okay, 3x plus y equals 4. If I want to get y alone, the only step I need to take is subtracting 3x. Now my y is alone, and I just manipulated or worked with the top equation, and now I'm going to plug negative 3x plus 4 into my bottom equation for y. So I have 2x plus 5y, and my y is negative 3x plus 4 equals 7. I'm going to erase. Actually, no, I'm just going to scoot this over. Again, remember your y here is negative 3x plus 4, which is also what y equals there, and we just substituted it in for y up here, okay? So I'm going to distribute my my 5. So 2x 5 times negative 3x is negative 15x. 5 times 4 is 20. 2x minus 15x is negative 13x. Whoa, I don't know why that's doing that. Here we go. And then I'm going to solve for x, so I'm going to subtract 20. And then divide by negative 13. So negative 13 divided by negative 13 is a positive 1. Now the nice thing about this is I can just substitute this 1 in for x up here. Because my y is alone, y equals a negative 3x plus 4. Could I have plugged in negative 1, because that's one of my answers. I'm trying to find y now. Could I have plugged in 1 in for the x for either one of these? Yeah, it doesn't matter which equation you use, but this one's going to be easiest because watch what happens. If I just plug in a 1 here, see, this is just y equals negative 3 plus 4. So y is 1. So now I write my point x, comma, y, which is 1, comma, 1, and that is my final answer.